The apriori method in the collection of significant values of pharmaceutical data. Наталья Маслова, Олена Любименко, Ольга Половинка и Ярослав Дорогий. Problem statement. The proliferation of sources and volumes of information, its diversity and distributed storage have led to the necessary of reviewing not only data collection and storage technologies, but also methods of analysis. Data meaning allows for the generation of new ideas and understandings of the nature and interrelationship of objects or phenomena. Typical data analysis tasks include the classification, clustering, association, rule meaning, anomaly detection, and others. The paper discussed approaches and methods for the analysis of structured data. It demonstrated how a data meaning method and the a priori algorithm can be used to uncover hidden relationship in large structured data sets, particularly in pharmaceutical logistics. Comparative analysis of the characteristics of a priori algorithm, variance used for association rule meaning is conducted, and modification of the a priori algorithm for processing structured distributed data using parallel methods in proposed. Result of application on various platforms, both existing and proposed variants of association rule meaning algorithm are present. Literature reviews is processing large volumes of data requires powerful computation resource efficient algorithm to ensure analysis speed and effectiveness and appropriate information storage and processing system. The literature number 1, 2, 3. Special importance lies in algorithm for processing in structured distributed data, which assimilate in various files such as finance, logistics, telecommunication, medical, etc. Number 4. The choice of a processing method and algorithm determines the research result and effectiveness. The most applicable method for processing both structured and unstructured large-scale data are data meaning method number 5. Research objects and subjects. Research objects process of intelligence analysis of unstructured large-scale data. Research subjects. Algorithm and method of intelligence data analysis in solving tasks of discovering hidden patterns. The research objective is to select platforms for the effective implementation of deep analysis algorithm, priori algorithm, considering the possibility of parallel and distributed data processing for large-scale data. Pharmaceutical data applicable in medical research and pharmaceutical logistics data are chosen as input data for conducting experiments. In this slide, you see methodical approaches to solve the problem of big data processing in pharmacology. As it is indicated that the main problems are distribution and performance. Modern technologies that support ideal algorithms and method are statistics data analysis programs, for example, Statistica, SAS, StatGraph, etc. Artificial neural networks, system or similar case, discussion three method, and evolutionary programming tools, genetic algorithms, limited sorting method, and data visualization system in multimedia national space. The main problems of processing most types of data can be solved due of parallel and distributed data meaning algorithm. Materials and methods. Recommendation for the use of information platforms designed for parallel and distributed processing of industrial data, on which the implementation of deep analysis algorithms, in particular the priori algorithm, will be the most effective in terms of speed and manufacturability in the data processing process. There are message passing interface method, OpenMP multiprocessing method, Hadoop, OpenSL, Spark, and Apache Flink. The platforms are organized by years of active entry into market and allow programmers to effectively use parallel computing resources to quickly and efficiently solve various tasks. In this slide, you can see technical characteristics of the clusters and result algorithm execution time of OpenMP and MPI for 1, 2, or 4 parallel processors. This slide demonstrates cluster diagrams and state of implementation of the priori algorithm on Hadoop platform. Next slide are experiments and results. The main results of descriptive descriptive comparison may aid researchers in selecting a data processing algorithm for large data sets using the a priori algorithm or in solving other data meaning tasks. Several data sets of varying size were prepared for the experiments. All data sets were stored in CSV files. This format is lightweight, contain no metadata, which is critical for reading large volumes of data. The experiments were conducted under some condition using a multi-core computer with variation on 2, 4, and 8 cores. For comparison, the author applied the parallelization and parallel processing algorithm described in the works, including in special literature number 12, and implementations of data analysis algorithm from popular open source data analysis libraries, namely RapidMiner and Weka, as well as with a parallel computing system based on the MapReduce model, Apache Spark Emlib. In Weka, the priori algorithm is a variable through the user interface and through the programming interface. Weka is mainly intended for use on a single server or workstation and doesn't have built-in support for distributed or parallel computing using graphical processor MPI or Hadoop. However, in combination with other tools and technologies, the Weka library can be used as a node in a general computation algorithm. In RapidMiner, the a priori algorithm is available as one of the modules for data analysis. Algorithm RapidMiner is not directly associated with MPI or Hadoop. It can be integrated with them for processing large volumes of data and distributed computing. Apache Spark Emlib is a library for machine learning that's a part of Apache Spark. Also, the a priori algorithm isn't part of the standard Apache Spark. It can be implementation using the Python programming language. The result of the experiments for various data analysis algorithms are presented in table 5. In this table, we can see Apache Spark, Mlib, result Dex Lopez, RapidMiner, and Weka algorithm. Next, figure 2 are demonstrate graphical interpretation of result as calculate time for the a priori algorithm on different platforms and data volumes. For example, Apache Spark, Mlib, DX Lopers, RapidMiner, and Weka. Conclusions. As a result of the study, findings have been obtained that both generals and advance of previous research conducted by the author. The focus of the work has been on selecting platforms for the efficient implementation of deep analyzing algorithm, especially an a priori algorithm. Considering the possibility of parallel and distributed data processing of large volumes. Pharmaceutical data applied to medical research and pharmaceutical logistic data were chosen as input data for the experiments. The characteristics of such data, notably their distributed, natural, and substantial volume, were highlighted. The following actions were undertaken in the study. The concept of big data and the challenges associated with the processing were examined. The necessity of applying modern algorithm to analyze unstructured data, such as the results of medical research and pharmaceutical data, including pharmaceutical logistic data, was confirmed. The a priori method was discussed as a tool for analysis data of significant volumes, and the study applied the author's quick sort program. And other. The instrumental tools for implementing the a priori algorithm for parallel and distributed processing, MPI, OpenMP, Hadoop, OpenSL, Spark, and Apache Flink platforms were analyzed. The peculiarities of applying their platforms in contracting algorithm for association rule meaning were described. Recommendations were provided and the results of applying each of the mentioned platforms were forecasted in terms of complexity, regular workload, and time of obtain results. Computational experiments were conducted for a case of using linear and for multiprocessor platforms in parallel implementation, confirming the analytical conclusions presented in the final sections of the work. Parts of further research were outlined and visioning a deeper experiment in the future application of parallel and distributed versions of association rule meaning algorithm in various fields. Including the medical pharmacological sphere with further integration of the a priori algorithm with machine learning methods. It's worth noting noting that the scientific novelty of the research lies in the conducted and integrated analysis of the characteristics of various information platform designed for parallel and distributed processing of unstructured data. It has been demonstrated which of this platform are implementation of deep analysis algorithm, including the a priori algorithm, will be most efficient of terms of speed and technological feasibility in the processing. It's all.